Hello and welcome back. Here we have a problem which is basically a curvilinear motion type of the problem. We're looking at a cloverleaf interchange that has a radius of curvature of 80 meters at the tightest part. So I'll write rho equals to 80 meters. It says, what is the fastest a car could travel around this curve without experiencing more than half a g in acceleration? And it says, assume the car is traveling at a constant speed. This is a way to say that tangential acceleration is 0. If v is constant, then derivative of it, which is at, is 0. So we want an to be half a g, 1/2 of, this is a metric problem, 9.81, which is 4.905 meters per second squared. So we have the acceleration, the normal component of acceleration, and we're after for this speed. So if I write the formula, an equals to v squared over rho, I want to solve for v. Therefore v is product of rho and an, square root of it is what I want. Square root of 80 times 4.905. This gives me a numerical value for speed in meters per second. If I take a calculator and do the numbers, I get 19.8 meters per second. So this is the corresponding speed. This is roughly equivalent to 44.3 miles per hour. Then, as far as the second part of the problem is concerned, let's call this part 1. Part 2, it says, if the car was instead increasing speed at a rate of 2 meters per second squared, meaning if tangential acceleration, which is change in speed, is 2 meters per second squared, what would be the new overall magnitude of the acceleration experienced by the passengers? So let's say this is path of motion, then velocity, let's see, we're after total acceleration. Then acceleration has two components, one tangent to the path, the other component towards center of curvature, which is an. Observe that I have two components of a vector. Their sum is what I call a. Recall magnitude of a vector can be found using Pythagorean theorem. So basically I want to take at squared and add it to an squared and take square root of it, which gives me 2 squared plus 4.905 squared. Taking a calculator and doing the numerical calculation, we have a total magnitude of 5.3 meters per second squared. Thanks for watching.